Hello there. So our look today is going to be on the three-dimensional aspects of area and volume. So we're going to start with a very simple one. We're going to start with our cuboid, or rectangular prism, whichever way you want to look at it. So in a cuboid or a rectangular prism, you're going to have some type of width, some type of length, and some type of height. Okay, so to get the area of this shape, you're going to need to multiply the front and the back to get their areas. So the area of the front is going to be the width by the height, and then times 2, because there's a front and back, plus the two sides, and they're a length by a height, and then the top and the bottom, and they're a length by a width. Sorry, I should just put brackets, don't bother with the x. So they'll be numbers. That'll be 2 times one number by another, plus 2 times one number by another, plus 2 times one number by another. Simple enough. Okay, the volume is a lot easier. Okay, for the volume of a rectangular prism, okay, it's literally just going to be the width by the length by the height. 3 of them together. That'll be in whatever squared, unit squared, and that'll be in unit cubed. Okay, now if you have the answer, so I'll go through one where you have the answer. Okay, so let's have a look. Right, so let's say the height there is 6, the length is 10, and the width is 4. So if I want to get the area of this, it's going to be 2 times 4 by 6 plus 2 times 4 by 10 plus 2 times 6 by 10. And just add them all up. Get your calculator, don't be brave here. Okay, that's just going to be 2 bracket 4 close bracket 6 plus 2 bracket 4 close bracket 10 plus 2 bracket 6 close bracket 10. That's 248 square units, or centimeters squared if it was done in centimeters. The volume is a lot easier, as you can tell. It's just going to be 4 times 10 times 6, which is 240, and it's cube units. Okay, now if they give you the answer, so for example, let's say they told it was 240, but let's say this one was missing. Okay, let's say this one was missing and it was just x, then how would I do it? Okay, well, let's say if the volume is 240, well, that's going to be 4 times 6 times x, so that's going to be 24x is equal to 240. Divide both sides by 24, x is 10. So that's the kind of way we do it. We've done this a million times with all the different ones. It's basically just divide, put the thing you know on the left, put all the other things on the right. They're all going to be multiplied together, and just divide by everything except the one you want. Okay, so that's a rectangular prism. Now let's talk about the special case. Let's talk about the cube. So a cube is special in one sense, in that all the sides are the same. So if we have a cube, but I know it doesn't look like a cube, let's assume it's a cube. Let's say I have a cube of 4 centimeters and you're just given one side. Well, then the area of that cube is just going to be 4, so that's one side, multiplied by any other side, 4 4s, and then multiply that by how many sides? There's 1, 2, 3, 4, 5, 6. So that's going to be the area. It's going to be one side multiplied by the other side multiplied by 6. So that's going to be 24 times 6. It's 144 centimeters squared. The volume is a lot easier. It's just going to be one side to the power of 3. 4 cubed is 64. So that's the beauty of that, okay? So that's your special version for the cuboid. Now, with all of these, you're going to have to, mix and match to get the ones you want, okay? So, that brings us on then to the cylinder, the sphere, and the cone, okay? Cylinder, the sphere, and the cone. Okay, so cylinder is the easiest one. What is a cylinder? A cylinder is two circles in a 3D sandwich, for want of a better word. It'll have some type of radius and some type of height. Okay, a sphere will just have some type of radius, and a cone will have a radius, a height from the center, and a length down along its side. So it'll have three things that are needed in them. So we'll have a look at the cylinder first, and then we'll work our way through the other two. So let's decompose the cylinder into its net. So if I imagine unraveling it, I'll get a circle, a rectangle, and another circle. So when I fold them over and wrap that around, I get back into that shape. Okay? So the volume of this. If I have a radius and I have a height, there's the height and there's the radius. So in order to find the volume, it's very simple. I just have to get the area of one of those circles. So we've done this before. The area of one of those circles is going to be pi r squared, and then multiply it by the height, how many of those circles are stacked up on top of each other. So that's the area. No, sorry, that's the volume. I don't know what I'm thinking. Sorry, that's the volume. The area is a lot more tricky. The area of the curve, this is the curved bit. It's the bit that wraps around. The area of the curve is just going to be that side multiplied by that side. Now that side is h, okay? But this side, you can only get this side by measuring the distance around the circle. And we know that the distance around the circle is 2 pi r. So the area is going to be 2 pi r h for the curved bit. If you need the area of the entire cylinder, curved plus top and bottom, you have to add that to two circles' areas. Okay? So again, I'll go through this now in an example. So, let's say I have a cylinder of radius 10 centimeters. And it has a height of 20 centimeters. Then the area of the curve is going to be 2 pi r h, which is 2 by pi by 10 by 20, which is, and you can use your calculator, 2 by pi by 10 by 20, 400 pi centimeters squared. The volume is going to be pi r squared h, which is pi by 10 squared by 20, which is pi by 10 squared by 20, which is 2,000 pi centimeters cubed. So that's a very straightforward one. Now again, I'm going to show you the trick. What happens if they give you one thing missing? So let's say they tell you that the volume is 2,000 pi, but find the height. Well then, look, if they tell you the volume, put in the volume formula. 2,000 pi is equal to pi multiplied by r squared multiplied by h. 2,000 pi is equal to pi multiplied by 10 squared multiplied by h. And like every other trick we've done, look, I know the left, I know everything on the right apart from the one I'm missing, so I'm just going to divide across. On your calculators, type in 2000 pi divided by pi multiplied by 10 squared, and you'll get the answer. Look, 2000 pi over pi multiplied by 10 squared, and you get 20, which is what it was. Okay, so that's cylinder. Now, sphere, same idea. Let's say a radius of 20 centimeters in this sphere. Okay, the area is going to be 4 pi r squared, and the volume is going to be 4 over 3 pi r cubed. Okay, so again, it really is. And then if it's a hemisphere, so there's a full sphere. If it's a hemisphere, just divide each of these answers. Well, you can't divide this one by, if it's a hemisphere and you just want the curved bit, divide them by 2. And if it's a volume, just divide it by 2. But that's only for the curve. Okay, so that's the full, and that's just for the curved half. If you're doing I'll show you the hemisphere one, where's the trick in a second. But let's try and work this one out just for the full sphere. So the area here is just going to be 4 by pi by 20 squared, which is 4 by 20 squared, 1600 pi centimeters squared. And the volume is going to be 4 over 3 multiplied by pi multiplied by 20 squared. 20 cubed. Now, sometimes you get awkward answers like these, but if you do, just write it down as you see it. 22 over 3 pi centimeters cubed. So there's your basic kind of answers. Now, I'm going to show you what happens if it's a hemisphere. So watch. If it's a hemisphere, the volume is very simple. It's just half the answer of a normal volume. So the volume of a hemisphere is just going to be 4 over 3 pi r cubed, and just divide the answer by 2. Literally, that's it. So again, if I go with 20 centimeters, that's just going to be, get a fraction going, and then 4 over 3 multiplied by pi multiplied by 20 cubed, and I'm going to divide that by 2. And there's your answer. 16 over 3 pi centimeters cubed. As you can see, it's just half that answer. Okay? Just half that answer. But the area, if it's just a curved area, it's just going to be half of that. However, usually when you cut something in half, like an orange or an apple, if they're a sphere, there's going to be a new surface produced. Okay? So in this case, there's a little bit of trick that you need. Tiny bit of a trick that you need. Okay? And that trick is, when you cut it in half, it doesn't become half. Because this bit becomes half, the curved bit halves, but you add in an extra circle. Okay? So instead of being 2 pi r squared, you add in the extra circle, it becomes 3 pi r squared. So 3 pi r squared, 3 times pi times 20 squared, 1200 pi. So it gets a little bit more than what you think, because you're not just cutting it in half, you're adding a little bit extra in. Okay? So just be aware of that. So that's a sphere. The cone. Cone is the same scenario. Cone has the very same scenario. Okay, so you take a circle, and we're talking about circular cones here. It's going to have a radius, and then it's going to have a straight line from the radius or the center right up to the apex, to the very top of the cone. So that's going to be its height, that's its radius, and then it has a length from the top right down to the edge, that's its length. And you can see this makes a right angle triangle. So the volume of this is 1 third pi r squared h. So pi r squared h, very similar to the cylinder, but it's the third of a cylinder basically. And then the curved surface area is going to be pi r l. So that's the curve. And if you want the total surface area, that's the curve plus an extra circle. So the total surface area is the curve bit plus the area of the circle that it's sitting on. Okay? So again, it's not too hard. It's the same kind of trick. Now, one little thing that can happen here, and I'm going to show it to you. If I was to look inside this, what I'm seeing is this. Radius, height, length. That's a right angle triangle, which means I can use Pythagoras to find one of these if I know the other two. Okay, so just be aware of that. Okay, with the cone.